All right, I think the audio should be good, so we're gonna go ahead and start. Hopefully everything works, because we're gonna try to do this in one shot. So just the goal of today's video, I guess, would be to talk about Meson and how it's just a build tool and how we can use that not only for PC projects, not only for Dreamcast projects or PSP projects as well, but really any sort of development. Definitely an entire replacement for things like new make or CMake or whatever other build system or build tool you use. I guess the syntax of it would be similar to CMake, but without all of the craziness and a lot less capitals everywhere, so a little less intimidating there. But also the format of the Meson Build files is generally a little simpler and very straightforward, very quick to edit, and the documentation on the Meson website is also fairly simple. At least in my opinion, it's not too complicated, and they have great examples of pretty much most things you would want to do fairly simply. Yeah, so we're gonna get started. So again, the tool we're talking about would be Meson, and it works on Windows, it works on Linux, I assume Mac as well. I don't have a Mac, but they do have a guide for it here as well, so it should work just fine. Pretty simple to install with your choice of package manager on Linux. I'll be using Fedora, so it'd be DNF, but if you were on one of the Debian likes or Arch, obviously use apt or pacman. If you use something else, I'm sure it exists somehow. Windows, you just download a binary release, pretty dead simple there. Mac OS looks like you use Brew, which I don't really know anything about, but I see it a lot mentioned, so should be a pretty common tool and easy to get up and running there. But yeah, so I guess the goal of today's demo would be really just how can we get a project like this is the Nihi 4 sample for OpenGL, pretty typical. Nothing too crazy there, but just a good test base because we have one source file, we use some libraries, and then obviously it's running on a Dreamcast, not Linux, so we have to handle kind of cross compilation there with the CallistoOS toolchain. So we'll talk about how we can achieve this with Meson, but then also how we can move on from that and also run the same project on Linux. Ignore the speed differences there. That's just my computer. It is woefully underpowered, so it really has issues emulating the Dreamcast with LXtreme Nitro. Yeah, it kind of actually makes things really confusing sometimes because things will look really slow when I run them in the emulator, and then I move them over to my Dreamcast and they run how you would expect. So again, ignore the speed difference there. It's the same code, just my computer not really handling the emulation well at all. So yeah, we'll get started on that. And there may be some kind of issues in this video. There may be some kind of awkward moments. I did prepare somewhat of a rough script and a fair amount of kind of setup directories and things, so it shouldn't be too bad, but we'll see. So this is what we're going to talk about today. We have two examples. We're going to first go through the just purely Dreamcast with Meson example, and then we'll kind of expand on that example as well if we wanted to do cross-compilation with multiple platforms, so in my case Linux and Dreamcast. Yeah, so again, the code we'll mainly be focusing on today is just going to be the Nihi 4 sample. So you can find that on a million places on the internet. Specifically, we have one from Simulant here from Kazad, already ready to go in a single file. So we'll probably take that and start with that. Copy that. And then we will move over to the live folder. This is a brand new folder I set up. I do have the complete folder finished, but we'll start from here. And hopefully this goes well. I'll be using VS Code. I know not everyone will be using that, but it should be fine for most people. So we'll start off, we'll make a folder called source. And we'll call this, I think I called it demo.c in the complete example. And we will paste in that sample code. And I mean, in my editor, you're going to see that there's some squiggles here because it can't find the includes. Because I'm running the Linux configuration. Probably fix that real quick. I didn't think about that for this demo. Let's see. This is not really relevant to what we're doing and just more a quirk of Visual Studio Code, but we paste in. So I have my 3 C++ profiles now. So we can click Dreamcast and it'll actually find all these folders. Again, not really relevant for this tutorial and really just affects how we're seeing the red lines or not. Not a huge deal. So we have that though. This is just the plain code. And next up, we are going to actually start writing our Meson file. So those files are going to be in a Meson.build file, which has its own syntax. Again, it's fairly simple, more reminiscent of CMake if you're familiar with that, but much simpler, and I find kind of a lot more powerful to do what you need to do. The only downside being that the Meson devs are fairly opinionated in their morals and how they think the software should work, so you are required to play within those rules. But still, everything you need to do should be possible. It may just potentially be a little unintuitive if you're going off the typical roadmap of a project. Things like if you have a tool that takes some input and then processes it and then makes a new input that you then use in your project, that can be a little awkward to set up if you're not used to that. But it is possible if you need to compile a tool that then you run that then takes input and then outputs something for a cross-compiled build. That can be done if you need to add dependencies that you would like to find in a myriad of ways. Say like for Linux, you'd use package conf. There's also other ways you can set up. You can also import CMake modules. Let's say that that is not really an option, like for GLDC in a moment. We'll set that up as a sub-project of this project, and then that would be available as well. Or things like typically at the end of a Dreamcast kind of full compilation, you would have a couple steps where you strip your binary and then potentially scramble it if you're into that, and I'll give you like a first read.bin or something familiar instead of just an elf. So that can be done as well. That's again a little awkward, but can be done. So let's go ahead here, and I am going to generally just be pasting lines into this file from the already completed one, but we'll talk about them. So this first line here defines what our project is going to be. So pretty straightforward. This is going to be your name, demo project. We are only using C. Give your project a version. This is just for you. and some default options for that C compiler. So we'll be using the C standard new 11. You could do other things if you're more familiar. You could obviously change that to C99 or whatever it may be. C++ 23 for you guys who are into that. So, and then we're actually going to start. I might just type this. It's not that much. Some compiler options is how I like to structure these files. This is not necessarily a best practices video or what the Meson devs preach or want you to do, but this is how I've been setting up things, and I think it goes pretty well, and it's pretty straightforward. So we're going to define a variable called argbase, and right, I have. So there actually is a Meson extension for VS Code that makes highlighting in these files, formatting, kind of linting, a little bit of autocomplete, but again, not needed. You're going to see they're pretty simple. So we'll add, these are just going to be compiler flags that we are going to pass later to GCC. So if you've ever added flags in a make file, this is going to look very familiar. So argbase will just hold 2 flags, turn on warnings, and we'll define Dreamcast. Arguments to the linker, we're not going to add anything in this project at all, but sometimes you will be adding things. Maybe you want to output a map file, or you need some more configuration. It can be useful here. We'll define platform includes. Again, all of these names are completely arbitrary, just choosing them because I think they are straightforward but useful in larger projects. Dependencies, I guess we could probably spell that correctly. So this is going to be the first line where things may look a little different. So we are going to get compiler C, which will just give you basically a Meson object that talks about the C compiler you're going to use. On Linux, it'll be GCC or Clang. On Dreamcast, it'll obviously be GCC, but Callisto OS flavored. So that just gets us that. And then the next line, we are going to use that compiler to find a library, libm. So just the math library, nothing crazy there, but pretty much everything uses it. So we are going to grab that as well. And then this brings us to argbase. So we have up top here argbase defined, and it is set to this array of flags. And we're going to add to it some more. This is not really necessary in this example, but we could have just put them all here and it would work the same, but just showing you that if you have an array of flags, you can then append another array of flags. So the pretty typical Dreamcast ones, mPretend cmove, single precision constant, omit the frame pointer, and then we get our 2 math helper intrinsics. So we'll grab those. And this next one is going to be a much bigger kind of topic. So libgldc project. And I'm going to type these out and then we'll talk about them. Okay. So we are going to explore this, but basically, in short, what this is doing is saying we're going to define a variable libgldc project for a subproject called libgl. And then from that project, we are going to get a libgldc dep variable, which would just be short for dependency. And then we are going to make a new variable for us called platform dependencies, where we're going to use that. Again, in this trivial example, we could just use this directly and it would be fine. I kind of like having these larger platform dependencies once you get into multiple platforms, because then in the final kind of binary command we'll see, you can just use platform dependencies and you will know that whatever platform you're compiling for, you have already added the dependencies. So like for Linux, we're going to have to use SDL, or no, we don't have to, but in this example, we'll be using SDL. We'll also be using glue, which is the GL extension wrangler, to get our implementation of OpenGL in a window. So that's how that goes, and it can just get a little simpler, because what if, like for Linux example, we're going to have two dependencies. So, you know, it can just be easier to define a list of them that you can update as you need per platform. And then we'll make another variable called argument C, and these will be arguments that go to the C compiler. Again, it's going to look odd because we're just making a new variable with our base flags that we've added to here as well. So kind of pointless in this example, but will be helpful later. Include directories basically says we are going to be looking here for header files for C and C++. So our source folder, again, this project doesn't have any, but if we did have header includes, we could make sure that they were all here so that when the actual compile commands are generated later, that all of our includes are set up correctly. Also, as far as a dependency goes, dependencies hold a lot of information as well. So the GLDC dependency will bring in its own set of include directories, so we can find our OpenGL headers, and it may also define other libraries that it needs. So if you think of, let's say, libping, like for PNG, that depends on libz for zlib to actually do the compression and decompression. So that would be an example of a library requiring another library. So you could set that up, and Meson would, if it wasn't able to validate all those dependencies, would give you a warning or an error that it couldn't find it. So now make another variable, source demo, and this is going to be a list of all of the actual files we're going to compile in this project. We just have the one, source demo.c, which is our Nihi sample 4 from GLDC. Just, again, nothing too shocking there. And some more what is going to look like duplication. We're just going to make another variable called source demo, or source that just holds source demo, and include that is going to hold our includes base. So that would be the includes for our project, and then platform includes as well, which is empty, but in the case of, oh man, let's say, so for Super Mario 64 port, that project for the PSP specifically had its own VRAM texture allocator I wrote. It was just a C file and a header file. So that was a additional file that the PSP platform needed, but only that platform needed. So that would obviously get included under platform includes. Here it's not needed, but just for completeness and for later. We'll have it so you can kind of see how this can change. So this is going to be the part where we define our executable for this project. You have different targets you can make, as it were. I'm sure that concept exists in CMake. In make itself, like new make, it is just, you know, you really define every step of it yourself. There's not really a concept of things, but so we are going to have an executable target here, which will be something that can actually run. It'll be a final binary or an ELF for most platforms, so we'll call it demo project. And its sources are going to include the source variable right above. And in this one, source is just a list of files, and we just have the one file, source demo. We could replace source here with source demo in this example. And it'll all work the same. We have include directories. That is going to be our include thing variable, which is the same as I just explained. cargs is going to hold our argc variable, which up here just has our base arguments. So our warnings are single define, and then kind of our Dreamcast platform ones. Our link args are going to be arg linker, which in this example is empty. We don't have anything special. I don't know why that capitalized that. Dependencies are going to include our libm for math and any platform dependencies, which in this example is just going to be libgldc. And install true. I don't actually think we need install true. I'm going to leave it because I have it in the example, but that is not going to necessarily be relevant. We're going to format that. Again, just part of VS Code. It doesn't need to be formatted, but it just makes it a little easier to understand. So this would be a mostly complete file at this point. It could be shorter. Obviously, we have a lot of duplication of things, but definitely functional. And we're going to need, obviously, one more piece of this puzzle, because while Meson knows about a lot of platforms, it doesn't know about our sh4 GCC toolchain that is CallistoOS flavored. So we are going to define that now. And what we do have instead are these things called Meson cross files, which in my opinion aren't super great. They are definitely a little strange and definitely very opinionated, but we change this over to Meson. So what we have here, this is a typical cross file for Meson. You could think of it, if you're familiar with the CMake toolchain file, very same thing. We're going to define our C compiler as SHL GCC, our C++ compiler, R for archives and libraries, strip. And then we can define some built-in options that get always included on top of any other project arguments. So we're going to make sure we just forcibly include all the cost includes. The one thing I have an issue with here is that you can't necessarily use the Meson functions here. So you can't use include directories. You have to just use typical like GCC argument for it. Same thing with, you can't actually define your own variables in here. You can define variables, but they get very strange. And then if you do define a variable in here, you can't then, like if I have a custom args and then I just force to show all errors, I can't actually add custom args in here. It won't find it, which I think is very odd, because that could definitely clean up some of these files for Dreamcast and kind of PSP a lot, in my opinion, but it doesn't work. I don't know if that's going to be planned to change. Originally, when I started using Meson for stuff, there's this bug I could exploit that would crash part of the Meson install or the Meson configuration process, and you could resume it, and it would actually bypass all of that. But then they actually added a lot better support for cross-platform, and cross-tool chain things. So it's definitely better now, but we're kind of stuck with these huge gross lines here. So nothing is really shocking here. This is pretty much, most people use the, I guess, bash shortcut KOS-CC, which silently does all of this for you. But here we just spell it out directly. So not too much to talk about. I haven't done anything for C++ here because I don't really know what those need. I don't use C++, I don't know it. So if somebody wants to volunteer what those should be here, that would be great. And then we have our prefix, libdir, bindir. We could use package.conf. We don't use package.conf currently in CallistoOS. Maybe we should. I know the PSP community got super into that, and it's been actually very beneficial for them, but we don't have it, so I just commented out. And then the host machine, Dreamcast, these actually do mean something, but you can also set them to arbitrary things. So we're just setting them to these. I don't necessarily know if these are the best we could do, but they're correct and they work. So system Dreamcast CPU family. Meson does actually know about the SH4 CPU family, so that is definitely correct there. System seems to be Linux, Windows, Mac OS, things like that. So Dreamcast is kind of an arbitrary choice there, but that's fine. And then we are a little endian. So that kind of goes over that. And if we were to use those, what that would look like is we'll run a Meson setup command for our Dreamcast builder. And then we will specify that we want to use that cross file. So this command, Meson setup, is just going to take this Meson build file, process it, and then actually generate what will be run later as a compilation step. So similar to how you run a CMake, and then it generates your build files, and you hit make after, and that will build it. So we're going to be in the folder DC builder, and then we're going to use our cross file. This is going to fail, but just so you can see what it looks like initially. The Meson build system, we have our source dir, builder, what our project is, version, what compiler we're using. It's going to be SHL, GCC 13. And then we have these here. So the build machine is where we are physically going to build this on. So this would be my Linux computer. Host machine and target machine are different. Feel free to read up on that in Meson about how they define them different. But typically you can just think of build machine and host machine, and that will be fine. If obviously you're building for the same platform, your build and host will be the same. If you're doing cross-compile, they'll be different. And then if you're doing this thing where you need to build something that then runs on a different platform, but then uses that to build for your final platform, would be when you might have all three different. That seems like an exceedingly rare situation. So we're not going to use it. It did find libm. And then we threw an error that the subproject directory nor a libgl.rat file was found, which is what we expected because we don't have that yet. So going back to, is this folder? It's our build folder at the moment. We have our Meson build, our cross file, and then our single source file. To actually use this subproject as libgl, all your subprojects go in a folder called subprojects. It is not negotiable. Meson has defined that as the folder, and that will be the folder. You can't change it. So in that folder, we will add a new folder called libgl, because that is what we have said here. And then in that folder, you would obviously put your libgl project. Now, this gets a little confusing as far as kind of where we are in this run through an example and things, but hopefully it should not be too bad. So since we have the power to, and since it almost makes more sense to, this subproject is going to be a code subproject. So there's, the actual code in here. We have containers, then we have GLDC itself. You can write other things like this error was talking about. You can write a wrap file that would instead just wrap a already compiled library. That way, if it was kind of tricky or you were unsure how to actually set up a Meson project for your sub-project or your dependencies, that way you could just use a pre-compiled one. But in the spirit of this tutorial, we are not going to be doing that. So we will instead, we're going to see how this looks. So why did this not show up here? Oh, because I did filtering. Okay, it doesn't matter. So we're going to move now to, this is our GLDC Meson Build file. And this folder can be fully self-contained. So you would be able to build this as well as its own project. So that's why this file looks very similar to the other one. So as a quick run through, this is GLDC project, C compiler again, define some default options for this project. Default library type is going to be static. Every library on the Dreamcast is static, so we're going to keep doing that. Hi, Bandit. Sorry, there's a storm outside. Same thing here. This is going to look very similar. We have our argument base, sets up our things. Argument warning, which I just made to hold all of our warning arguments. All these names are completely arbitrary as far as the variables. Arguments code, just define our two defines. Still going to get the Meson compiler for libm. Set up our arguments. We have our include directories folder as include, which holds a GL folder that has gl.h, glext.h, cos, and glue. Source library is going to be gldc.c, which is just one big file that combines all the other files. A long time ago, there was better performance if it was compiled that way. I don't know if that has changed, but literally that file just includes all of the C files and then compiles it. Yeah, who knows? All in the name of performance and optimizations. But this could have every file listed individually if you so choose. These are all just lists with brackets. Same thing, we have our source, library, include base. And then this is the part where it differs from our example one. Instead of an executable, we're going to say static library, because that is what this subproject is actually building. Going to give it a name, GLDC. We have our sources here, include directory, cargs or arg linker. It only depends on math. And then this next line is very helpful for the subprojectness of this. We're going to define libgldc_dep as a dependency. And this dependency is itself. And we're saying that this dependency needs all the include directories and it links with this static library. what that means is that when we pull this variable in our project, that we are going to include that here. So that is how we can set up a subproject that we will then use in another project, which in this case we need because we don't really have a better way to include GLDC at the moment, and I like having kind of atomic repositories where all the dependencies are in it and we can rebuild it. So we will run setup again now that we have that subproject set up, and we get slightly different output. We can see that we found libm again. We have one build target. We were able to configure the subproject, and we see demo project version 0.1 is linked with libgl that was found and configured. So now we can issue our next command, Meson compile -c. I never get tab completion for this command, but so this command is going to say, using the setup we have, and compile it, and -c just changes which folder you're talking about. We set it up in DC builder, so we will compile that folder, and it is going to compile. It's done. Linking target, demo project. So now, which window? This window. We come to the builder. We have demo project, which is an ELF. It doesn't have a .elf extension, but that's just because I'm lazy. But this is our Dreamcast ELF. So if we come back to here, we can run a command for your emulator, or you could use like DC load if you want to test this on a Dreamcast. However you want to run an ELF. We're just going to use LXtreme Nitro. Again, shoutouts to Kazad. And we'll just run that ELF as is. We get my custom ip.bin, and then we can see it runs. And then we can see that we did initialize GLDC, and it's obviously working. Nothing very surprising there. But that was Meson taking that sample C file and then doing a cross-compilation with a subproject of libgl, which is really GLDC, and compiling that all for us. The nicer thing is it's very quick. It's a very fast compilation system. Syntax, pretty simple to understand. Even I'd say most people who aren't familiar with Meson could at least look at this file and get a pretty good idea of what's actually happening. I don't think there'd be a lot of confusion there. They may not be able to write one, but they could at least open one and understand it, and then potentially just kind of hack on it, edit what they needed for larger projects. So that is going to, I guess, conclude part 1 of this. And then in part 2, we're going to expand on this same example, but look into rewriting this Meson.build file and then to handle running on Linux and Dreamcast from the same code base and allowing us to compile to different platforms with the same project. There's also going to be some code changes. Those are going to be mostly relevant, so I probably won't go over those much, but there's going to be a couple of code changes because obviously Linux doesn't know about glcost off buffers or glcost init, and same thing on Linux. We need some way to actually make a window and get an OpenGL context and set all that up, and it would just get messy putting this all in one file. But we could, I think it would almost make this example more confusing if this file was just had if defs everywhere and it got really crazy, but maybe it wouldn't, who knows. Anyway, so that's the example, and I'll be right back.